Hello. Hi. So I am now going to be recording all the steps needed to perform a couple of analyses using satellite data that we routinely perform every time we have polygons. And those are the Griscom et al. Reforestation potential analysis and also the modus land cover or Sentinel-3 dynamic world land cover change detection analysis. So specifically today we're going to be looking at polygons from Indonesia and Mozambique for which we are doing the estimations. So the steps are going to be exactly the same for Indonesia as it's going to be for Mozambique. So I'll do one after the other and I will walk through absolutely each of the steps. So the first data set that we want to look at is Griscom et al. 2017. So that is a popular PNAS paper where Griscom and his other authors are estimating a reforestation potential map, and this is a product that has been produced at a global scale at a 750-meter resolution. And they actually ended up doing this by looking at various natural climate solutions projects that exist in different registries and have an estimate of their average biomass density for different points. So wherever it's available, they kind of average across all the projects and their estimates to get a reforestation potential number. And for parts of the world that it's not available, I think they use some meaningful kind of interpolation to be able to derive the map. The best thing about this entire paper, which you can also download and read, is that they provide the data set. So this is the global spatial data set that's available on Zenodo. Zenodo's data repository mainly for research, where authors of papers can optionally make their data sets available. So specifically, they've made this data set available, and you see there's a TIFF file. TIFF is the image format, or and sometimes it's geocoded, so it's called a geotiff. But that is a 3.8 GB file that we will be looking at and trying to reduce in order to form the estimate or the average reforestation potential estimate for our region of interest. So thankfully, I've already downloaded this data set and I will look at where that is. I think I brought it into one of these. It's not here. Let's see. No, it's not here either. But I know for a fact that it's in this folder. So let me just go and get it. There it is. So I'm gonna take those into. Where is it? Okay. I'm just gonna drag that to the top and kind of get it into maybe there. Okay, so we have that going. Uh, reason we don't really need that, but I will nevertheless kind of move that one level up. Gosh, well, we don't really need that, to be honest. Okay, not to worry. So we know we have the data set here. The next thing we're going to obviously need to know is I'll just talk about a little briefly about the other data sets which we will be looking at for the analysis for the other analysis. So this is Modus yearly land cover data set, which is at a 500-meter resolution from Google Earth Engine, and that is available from 2001 till 2021 January, and it's provided by NASA's LPDAC. Uh, so this provides several kinds of land cover types. So this is the land cover type class table. So it breaks down the surface of the Earth at a global scale into 17 different land cover types, of which five of them are forests. So land cover type number one, two, three, four, and five are forests. So that's the ones, and the changes in the percentage land cover type over time is what we will try to study as deforestation rates. And obviously, we'll also want to observe how the areas such as shrublands and savannas and grasslands are changing to see if any of those become suitable for reforestation. So this is one of the data sets. And sometimes we end up having polygons which are actually really quite small, and it doesn't really make sense to use a 500-meter resolution data set. You actually want to use something much more detailed. So 10-meter resolution data set is Dynamic World, and Dynamic World is actually has its own website, but you don't need to worry about that. But basically, this has been derived from if I remember right, Sentinel-3. But I also know that's available in Google Earth Engine. So I just want to look at the description. Oh, okay, it's available from Sentinel-2. Sentinel-2 has typically a 30-meter resolution, and I believe that this is even more downscaled to the 10-meter resolution. So, but the only shortcomings here is that Dynamic World only has one, two, three, four, five, six, seven, eight, nine different land cover types. And the forest land cover type that we care about seems to be mapped to trees. No, this is roughly okay if we're just trying to derive deforestation rates based on this. However, sometimes trees and forests aren't actually the same. So, trees need to be really contiguous and co-located meaningfully in order for them to become a forest biome. Like relatively immature tree plantations don't necessarily come with the same level of biomass density. But nevertheless, if you have some trees within our polygon, it ends up picking those up as percentage trees. So sometimes we don't get a very meaningful deforestation rate change detection using only this land cover type. But when we have a really small area of interests, which is even smaller, where the 500-meter resolution is not dense enough to work for our cause, this is the best cursory estimate we can get. The other thing is trees are also sometimes in urban settings, you'll find trees, uh, and you'll find trees on the street, but you'll also find trees in parks rather. So uh, just for the record, urban trees on the street don't necessarily give the same biomass density as an entire set of co-located trees that constitute, a forest biome. So this is this while this is a 10 meters resolution data set, it has its shortcomings. So these are the things we will be looking at. This is a live data set. So you have a snapshot of this event as of today, which is 11th of April 2023. uh, for these we don't really actually have to download the data set. I this is the JavaScript code that one could actually enter into Google Earth Engine to get the data if they wanted. But I have a slightly different Python package which does the same thing, which establishes a connection to Google Earth Engine server and pulls the data out. So I'll walk through that as well. Okay, so without further ado, we'll leave the land cover analysis for the second part, but let's talk about deriving Griscom et al. Reforestation potential. So this is pretty simple. We know that we have the Griscom data. The next thing we really want to look for is the polygons. We need the polygons within which we actually have to look at the reforestation potential. So for the Indonesia project, Indonesia MHP project, I've received some shapefiles. So I want to go and look at which shapefile that we need to look at. I know for certain it's the 16,000 hectares where we want to look at. It's saved in the S3 shapefile format, which is not just one file but tends to be about 7 files if you're familiar with this format type. But nevertheless, the .shp file is something we can drag into a QGIS interface and it'll work. So it's great. We have this shape file for us to use. Now let's look at Mozambique. We'll want to create a shape file for that as well, because we'll want to look at the same Griscom dataset within that region of interest. Uh, I've received this as a potential area of interest. I'll show you what it is. It looks to be some kind of polygon within Mozambique, and I've been given 12 rough points with an X and Y coordinate references. Just by looking at the coordinates, I can't really tell what coordinate reference system it is in. I have to do something in order to be able to sketch out this polygon, right? So sometimes when you don't really have polygons available but only receive things like this, you have to resort to certain methods to be able to build yourself a shape file of its own that's compatible with QGIS. Either you could use these XY points, plot all the points, and derive your own polygon. An alternative way to do it is to use some plugin where you import this image into QGIS and then sketch it out on top of that. Let's see what I can do. I see some other red kind of lines going around, which probably could be the districts within Mozambique. So I have to make some kind of educated guess and work on this. I know this is called Reserva Recreativa Privada do Rio Save. So if I'm pronouncing that anywhere close to correct. But okay, let's try and find what this is. So let me put this on the second screen. Let's go to Google and search for Recreativa Privada do Rio Save. So it seems like just by trying to translate this, it seems like some kind of private conservation land around the river Save. So yeah, it seems like this is already a park, national park, or some kind of conserved area. So just searching like that, the way it is, doesn't yield anything. But I know this website called Protected Planet, which actually has protected areas of interest. So some of these kind of websites are just geo data repositories from where you could go and find polygons uh, from different countries, or for different purposes. And this is the website that actually has a lot of polygons for forests. So I'm going to see whether I can actually go to Mozambique and find whether this whole uh, protected land exists, and I can just download that polygon. So I'm going to search for by countries, and I'll just search for Mozambique. And yeah, we have Mozambique, and it says 58 protected areas. Hopefully, one we're looking for is right there. It's got to be one of these, right? And interesting. It doesn't. So either I can view all. Let's see if it's on this list, and I only pick that up. If not, I'll have to download the entire set of all protected areas, and then we'll look at it. It's primarias et segundas. Oop. Zambezi Delta. I know that roughly this area is in the Zambezi Delta, but that's definitely not good enough for our purposes, right? We just need to know Recreativo Privada. Right, here we are. Yeah, it's Maputo. This is tricky, tricky. Okay, we are not fortunate at this, so we may have to do something to sketch this out, right? Uh, Let me see whether this video is going okay. Yeah, seems to be going okay. I have 6 minutes more. to record this. It's 30 minutes max. Okay, so we are going to need to do something clearly to sketch this out on a map of Mozambique. So the one thing I'm going to do is download the Zambezi Delta polygon because I know that this is in the Zambezi Delta. So let's download that polygon. And the way to do that is you have all of these. You have all of this. That's fine. I think all we need to do is just click download and shapefile. And then we have a shapefile. You need to include this as a citation. So I'm gonna start a file for Mozambique here. We'll start a Google Slides where on some page I will have this citation so that we can include it later. Yeah. Okay, great. Let's come in here. I gotta click download again. Okay. Interesting. It has downloaded. Let's go back, bring it into Mozambique, unpack it, and see what it has. Okay, it seems to have another zip file. Let's unzip that. We have a shape. Okay, so we're going to need to put this on a map of Mozambique to look at. So I'm also going to go and try to get Mozambique administrative divisions, UN OCHA, I think. So from if we go to humanitarian data exchange, uh, or humanitariandata.org HDX, this is where you can really get like boundary polygons of countries and their administrative divisions, either level 0, level 1, etc. Just from looking at this, I'm not really sure that this seems to be the level 0, level 1, level 2, level 3 shapefiles, which is far more than sufficient. So I'm going to download this. So it's country, province, district, and posto, which is great. Okay. So I have this. Yeah. So I have this. Bring it into Mozambique. Let's unpack that. Okay, great. We have level 1 files and we have the level 1 shapefile. I think we have enough what we need to start exploring Mozambique, but I'm also just going to download Indonesia administrative divisions. You have to actually write the name of some kind of geodata service in order to get it. Let me try DivaGIS. Uh, they said, oh yeah, okay. We see humanitarian data exchange already has Indonesia, so we don't need to go to DivaGIS. This looks pretty good. Okay, level 0, 1, and 2. That's more than sufficient. We don't need level 4, the village level, but no, this already has it. Great. Let's get this. I think this is a pretty dense data set with many, many objects in this shapefile, so it's going to take some time. But yeah, we'll wait for this. We'll set up our shapefiles in this video and maybe make a subsequent video where we do Griscom also. Okay, in the meantime, I am going to open QGIS. This is what I really use to quickly look at things. A lot of the QGIS workflows can also be operated using Python or R, another language. So everything that you do using the UI tools in QGIS, you could just as well execute and set up as a workflow for your geospatial uh, image files and spatial, shape files using Python. But we can look at that at a later time. For now, I just want to look at everything we have from Mozambique, and we need to be able to draw a polygon of this Reserva Recreativa, right? So let's first bring on board a base map. So we have a new project going on, have nothing on there. I think we should add a Google Maps base map, right? So this is just a map of the world, and it's as you zoom, it gets denser and denser. That's how a map is set up. So now I'm zoomed in on Mozambique. I'm going to add the shape file from here, which is the Zambezi Delta. And I'm also going to add the administrative level 1 shapefile. So let's bring this behind. Interesting. Now it starts to tell a story. Uh, as you can see, what I will then do is go and change the. So when I double click on this layer, which is now in dark orange, I will be able to edit the properties of this layer. So I just want to actually change, in order to be able to also view the base map. What I do first is I kind of make it a slight gray and give it a certain level of transparency so I can see the base map underneath it. This is the Zambezi Delta that we know we're working somewhere close to. So I am also going to change this and just make it a red outline so that I can work within that. And now somehow I need to be able to bring in this image overlaid on top of the Zambezi Delta area, and then sketch out this exact shape. Interesting. Es poco por si. So now, interesting. This is in Portuguese. Maybe let me check what we do with that. So I am going to get in here. We almost have the Indonesia boundaries, but I just want to check what this word means. Es poco por si. Por si. So now. Translate Portuguese. I think it's Portuguese because Sketch by itself just don't give you. It has to be Portuguese because it's, yeah. I have all the accents now, but yeah, it just says Sketch by itself. Does not give you something. So we don't really have much here. We're gonna have to construct this polygon in some other way. Okay, no problem. Um, okay, so one thing I will try to do is probably Indonesia is downloaded, so let's get the Indonesia polygon into MHP, which we will need to use, unpack it. It's unzipped now. Okay, I have administrative boundary shape level 1 shape files, so I'll need to use that at some point. So I'm happy with that. It's just Mozambique's polygon that we're focusing with. Now that we understand all these, how to get all these data, we are quite okay. So yeah, we can close this. I can see that it says Distrito de Govuru, so I'm guessing it's in the district of Govuru. No problem. So though we need to be able to draw out this polygon, right? I'll check on time. Okay, 25 minutes. I'm gonna stop this video and make another one for part two. See you in part two.